show that f and g are inverses of each other, so more of the same. I want to know if f of g of x, is that equal to x? That's what I need to know. Well, in the function f, wherever there's an x, I'm going to put g of x, which is 2 over x. So this would be 2 over x minus 5. So I'm going to replace the x by 2 over x. Yes, I see what you mean, plus 5. I was looking because there's a 5 here and a 5 there, so I wasn't sure what 5 you were talking about. Now this makes life kind of easy because I have 2 over x plus 5 minus 5. Well, plus 5 minus 5 is 0. So I have 2 over x. This is where complex fractions come from. They are created things, not like the kind of things that we've been working with earlier. So if you remember, this is 2 over 1 divided by 2 over x. So what do I need to do? Yeah, invert and multiply. And now the 2's reduce out. And x, and it verifies that these two guys are inverses of each other. So yes, they are inverses. Now these guys are very likely inverses of each other, and I look at it because one is cube root and one is x cubed. And what do you know about cube root and x cubed? Yeah, they undo each other, right? You undo a cube by cube rooting it, and you undo a cube root by cubing it. So if I'm looking at the inverse of x cubed or the inverse of cube root, you're going to expect to see one in the other because they do undo each other. So we're going to be looking at f of g of x. We wanted to see if it's going to be equal to x. So f of g of x, is that equal to x? That means it verifies if it does. So that says in the function f, I'm going to pull the x's out and put g. So that means in x, that's the f, that's the cube root of x minus 4. And I'm going to put x cubed plus 4 in its place, where the x's are. This becomes the cube root of x cubed plus 4 minus 4. Plus 4 minus 4 adds to 0, which is the cube root of x cubed, and the cube root of x cubed is x, and it verifies, so yes, inverses. So that's why you have to have cube root in there, because you end up with an x cubed, and it's got to undo x cubed. Cool, huh?